Hello all and welcome back. So in this video, we are going to compare linked list with an array or a list. Now, the reason we were doing so many operations in the past few videos was to make sure that we are comfortable with each operation and we are able to understand the complexities which are involved in each and every operation. The same I believe will be very helpful tomorrow when we will be making some software, or let's say when we are trying to optimize any code. So for that matter, now let us deep down based on all the understanding which we have gathered till now, we will be able to make some idea that where linked list can be used and where arrays can be used, which I believe is very important. Our aim is not to just solve question, but to become better problem solver. Okay, so let's get started everyone. Let me write down the headings first. So say array or list. Now these are kind of analogous. We have seen them, and linked list. Great. So the very first thing which we are going to compare them is the access. Now accessing anything in my array is very straightforward, right? We can just use the index. Indexing is there present with us. So it is O of 1, right? We can directly access anything. The reason they are stored in continuous format. So if you tell me where the first one is, just by simple addition, I can reach to the, let's say, fifth one or 100th one, right? On the other hand, linked list, it is O of n. And of course, big O is the worst case complexity. So to go to the tail, I will have to go on each and every node. Next is memory management. Now, in memory management, our array, right? It was of a fixed size. And this I'm talking about the very basic array, right? The one which we discussed in the starting. It is of fixed size where ideally some used to be vacant while some can be filled. But the major point was that memory fragmentation was not possible. Memory fragmentation was not possible. So we can have a case where lots of memory is getting wasted, right? Or we can in a way end up with less memory as well. But I am taking the case here where we have the exact, like we have the extra memory because we are able to store each and every of our elements, right? So memory, let me write it clearly. Fragmentation, not possible. On the other hand, in my linked list, memory fragmentation is possible. So what happened here is no unused memory, right? No unused memory. That was the whole idea. All nodes have data, right? We don't have any concept of vacant nodes in linked list, right? All nodes have data. And one more thing I would like to add here, we do use some extra memory for my pointers, right? So we use some extra memory for my pointers. Great, everyone. So I can write that memory fragmentation possible, right? Great. Now let us move forward and discuss with respect to insertion. Okay. So if we have a insert kind of an operation, so let us discuss that as well, everyone. Considering insertion in an array, if you have to insert at start, On is the complexity, right? Whereas if it is not full, let's say if you have to insert at end and your array is not full. So end not full, like space is there. So it's going to be O1 because we can just find out that okay, where it is ending. And if we know some space is there, we will just access that memory and change the data. But again, if it is full, then it's going to be O of n, right? Now in linked list, the insertion is again O of 1 at head, but at the end, it's always O of n. At tail, I'm going to write here something which we have done, right? Now, if we talk about, let's say, middle, if we talk about middle, then it's going to be O of n only. Like I will write it as O of n by 2. So it can be O of n only for a very big n. And in linked list as well, if let's say you are asking me to insert at middle, okay, so I can maybe first find the length, then divide it by 2. It's going to be O of n only, right? So I hope that is clear, everyone. Now let us move forward again and see few more things. Based on this discussion, now again, we can write for deletion and other operation as well, right? That is not a problem. But few things will be a lot clear. That is, arrays are very good if we have to use indexing. So they are very good for indexing. On the other hand, linked lists are very good if we have to insert or delete from my head, right? So if you have some operation where we have many insertion, I think you can use linked list because no memory is getting wasted and it is very fast, right? So on that note, arrays of course are very read fast because you can read so quickly from that because of indexing. When it comes to write, linked list are the one which we can use because we can easily add on the head and then keep on moving. You can even think that you are storing linked list in a reverse format, in a reverse manner, right? So it is read fast. So anywhere where we have so many read operations, array seems to work there, right? On the other hand, if we have so many write operations, then linked list seems to work there. Okay. Great, everyone. Yeah, I think these are the major differences. Again, there can be lots of them, but I just wanted to make sure that you understand the basic idea that how they are compared. Right now, you can again compare so many of the complexities of deleting at head, at middle, but we will be able to find them out. Right? That questions we have done very nicely each and every operations by going a lot in depth. Pretty sure you must have also done all these assignments as homework which I have given you along with the solution video. So now with this clear, with this whole overall idea clear, I hope in future when someone asks you, you will be able to better explain that why we are creating linked list, few benefits as well as how they overall get compared with an array. Okay, everyone. So hope that was clear. Let's meet in the next video. Thank you.